Hello, Mrs. Brown here. I want to go through a little bit on memory and cognition with you today. All right, so when we talk about memory in psychology, memory is a system that works to encode, store, and retrieve information. So this deals with how do we take in information, where does it get stored in the brain, and how can we get that information out when we need to use it to make sense of the world around us. So we talk about three basic tasks of memory: encoding, storage, and retrieval, and story, if you will. And so each of these has a job and a task that has to deal with memory. Encoding is putting information into the brain. So we do this through the process of sensation, and we use selective attention to decide what information we're going to take in and encode from sensation. One thing that we can do to increase our chances of encoding information purposefully is using elaboration. Sometimes we call this semantic encoding, trying to understand the information and make it meaningful to you. Maybe you connect on prior learning, or you connect it to something that you already understand. That will increase your chances of encoding information. So whether or not we take this in has to do with our intention of taking in information and selective attention. Once we get information into our brain, then we need to keep it there. If we don't have a reason to keep it, oftentimes those short-term memories we don't store in the brain. If we do have a reason to keep it, or we've connected it to something important or meaningful to us, then oftentimes we will store that information in long-term memory so that we can retrieve it when we need to use it. All right, so what is retrieval? Retrieval is getting stuff out of our brain. How can, when we need that information, whether it's factual, declarative information, or even procedural memories, how can we get that out of our brain? All right, so going through these basic tasks of memory a little bit more in detail, like I said, the first task is encoding. So we have encoding, storage, and retrieval. So here's a list. I want you to go ahead and try to remember this. I'll give you a minute. All right, now go ahead and try to repeat it back. It's hard, isn't it? Maybe you remembered some of it. Maybe you remembered that it was capital letters or the first or the last, but it's very difficult for people to remember the whole thing. All right, and that's because there's no real meaning behind those random groupings of letters. Let's try this one. All right, so let's see if you can remember this one. Now, the previous one was what we call visual encoding, just trying to process information by what it looked like. That was very difficult. This one is a different type of encoding, so try to remember it. All right, what did it say? Pain, crane, sane, lane. All right, if you got that one a little bit easier than the first one, that's because this makes use of what we call acoustic encoding. Acoustic encoding, just like it sounds, haha, get it? Sound, uses sound to help you process information. So if you're a musician, you may have heard, oh, you know, the acoustics of this song or the acoustics of this room. Same kind of concept. It means processing information by sound. This is why alliteration in language makes it easier for us to remember things. And this is more effective. It's a more effective type of encoding than visual encoding, which was the first one. Now, what we do know is that when we combine different types of encoding, we have even more of a chance of remembering. So technically, you read the words as well, and you said it in your head, it rhymed, it had that acoustic encoding. So you technically made use of two different types of encoding at the same time, which meant that it was probably even easier for you to remember that. Now try this one at the bottom. Apples are grown in Washington. Try to remember this one. All right, what was it? Yes, apples are grown in Washington. Hopefully, this one was the easiest one for you to remember. And the reason was, yes, we made use of acoustic and visual encoding. I said it out loud to you and you read it. But also, we use the most powerful type of encoding, which is semantic encoding. Semantic is when you make information meaningful to you. All right, so sometimes this is done through the process of elaboration, but it's connecting it to your prior experiences, understanding what it means, and making it meaningful to you. And when the information is meaningful to you, relevant to you and to your life, you're more likely to remember it. All right, so this is the most powerful type of encoding. And this is why oftentimes when you learn new things, your teachers try to connect it to previous things that you've learned or make the information relevant to your life, because they're trying to make use of that semantic encoding, which increases the chances of you really taking in that information, storing it, and being able to retrieve it later on. All right, so here we can see the percentage of people who recognize something, much higher percentage with making use of semantic encoding. That is the best one to use. We also know that we want to combine, that would be even better than just semantic, that we combined all these different types of encoding. But semantic is the most effective, followed by acoustic and then visual. Now, none of this really makes a difference if you're not paying attention to your sensations and the information around you to take it in to begin with. So in order to encode information, you must have paid selective attention to that information. Remember, we talked about selective attention before with sensation, and the cocktail party effect was an example of this. So this, in order to take in any information and encode it, we must be paying attention to it. Now, how else can we have effective encoding besides making use of semantic encoding and maybe combining some of those different methods? There are several things that we can do to make our encoding more effective with the hopes that we'll convert information into long-term memory. One thing we can do is rehearsal. All right, this is a process of repeating and reviewing information. If you are actively reviewing information right before a test or repeating it to yourself, maybe someone's said, oh, my phone number is, 571-333-4445, okay? Then you start saying 571-333-4445, 571-333-4445. You start saying that to yourself. You're making use of rehearsal. So what we know is that when we're actively rehearsing information, this makes the encoding of that information more effective, helps keep it in our short-term memory in the short term, and potentially helps convert it to long-term memory. We also know that in order to take in information and keep that information, that the best way to do this is to take in that information and rehearse and review that information over multiple experiences, over multiple times of experiencing that, versus trying to do it all at once, and that we have more reliable memories if the review is spaced out. This is a concept called the spacing effect, put out by Ebbinghaus. This is also called distributed practice. I tell my students all the time, make use of distributed practice. When you are learning and reading and reviewing for your test, do a little bit every day, instead of trying to do it all at once, like cramming the day before it's due or the day before the test, because your brain is more effective at encoding information if you distribute that practice over multiple experiences over time versus just trying to do it all at once and cramming. All right, we also know we can make it meaningful to us, use elaboration, and we also can tie in our personal interests and personal memories, right? So this is a type of elaboration called the self-reference effect. So if we make it related to something that we remember or have experienced, we're more likely to remember that. Other things that we can do, we can use mnemonic devices. So we've been talking about these all year, coming up with a clever or catchy way to remember it, right? So some of the different things that we've done when we did same for sensory is afferent and motor is efferent neurons, right? Using the mnemonic same was something that helped us. So coming up with different ways, maybe a little song or something you think of, a flashbulb memory, something you'll never forget because it has that emotional attachment, and then you think of the light bulb, whatever you want to do to come up with that mnemonic. We also know that chunking is something we can make use of. Taking large amounts of information and breaking it down into smaller, more manageable units. We see this with phone numbers. We have an area code that's 3 numbers. We have 3 numbers after that and 4 numbers after that. It is much easier for us to memorize phone numbers when we do 703-222-6868 versus when we do 703-222-6868 all at once. So it's easier for us to break it down into those smaller, more manageable units. This also helps with the amount of capacity we have for storing information, and we're going to get to this, that 7 plus or minus 2 items for every person. So chunking is something that we can do. How can we organize large amounts of information into smaller categories and more manageable units to help us remember that? We can also use hierarchies. So thinking about how our concepts are related to each other, is there a breakdown of larger concepts and smaller concepts underneath? We did this when we did the breakdown of the nervous system, right? We said, all right, first thing we have is the central nervous system and the peripheral nervous system. And then we broke it down into these other different smaller parts of the nervous system. So that visual and that understanding of how it's all related into the broader and more narrow concepts is something that helps us to remember. All right, so let's talk about a couple of other things in terms of encoding. I want you to try to remember this grocery list. Go ahead and pause this video, take a minute, and don't write anything down, but see if you can come up with a way to remember this list. All right, so hopefully you came up with a way to remember this list. Let's see who can remember it. Were you able to remember everything on the list? Milk, eggs, butter, bread, celery, chocolate, big red beans, and chips? It was probably difficult for some of you. Some of you maybe use some of those different techniques to remember this. But I bet a lot of you remember the things at the beginning and or at the end of the list, but maybe miss some of those middle things, bread, celery, chocolate, big red. And the reason could be because of another theory of Ebbinghaus, the serial position effect. Notice serial like numbers, the location on the list, not like Kellogg's or Lucky Charms, okay? And so the serial position effect says that we are more likely to remember the things at the beginning and at the end of a list, but forget the things in the middle. And the reason this is because of 2 different effects, the primacy effect and the recency effect. So recency is we remember the things at the end of the list because they were more recently recalled. We heard them last, they're more fresh in our mind. The primacy effect is that we remember the stuff at the beginning of the list because we had more time to rehearse those items. And as a result of primacy and recency, we might forget the things in the middle. All right, so keep this in mind as you're trying to remember things in a list. The serial position effect might make it more likely that you forget the things in the middle of the list. All right, this is the end of this video. In the next section, we're going to talk about storage of information.